We are officially through the first 5 chapters out of a total of 10 chapters that we have to cover inside of this course. But don't stop now, because we have some very important topics to cover in the second half of this course. We're going to discuss architecture enforcement, reliable messaging, event-driven architecture, testing modular monoliths, and how to build a microservices architecture. If you're enjoying the course so far, I have 2 small asks to make. First, I'd like to invite you to leave a testimonial and share a review about this course, and you can do so from the form that's going to be right under this video. You have 2 options for a testimonial. You can either leave a video testimonial or a text testimonial, whichever one you prefer. Secondly, I would like to invite you to join my affiliate program. You will get a unique link that you can share with your friends, colleagues, on social media, or on your website, and you will get 25% out of every sale you make. So these are the 2 small favors that I'm asking of you. Leave a testimonial right under this video, and also consider joining my affiliate program. And with this, we can conclude this quick intermission, and remember, we have some very important topics to cover in the second half of this course. Thanks a lot for watching this intermission, and I'll see you in the next chapter. Welcome to the next chapter in this course, and in this chapter we will be talking about architecture enforcement. The modular monolith architecture is a relatively complex architectural style. We have our modules encapsulating the required business functionalities. We also have separate components for solving cross-cutting concerns, and then we need a way to bring everything together at runtime so that we can expose an interface to the outside world. In our implementation, this would be an ASP.NET Core Web API, bringing together the users, events, ticketing, and attendance modules. Now, any software architecture is only as good as its weakest component, and if it's really easy to bypass some design rules, your architecture will inevitably start to crumble. So in this chapter, I want to give you a few guidelines for how you can both build the modular monolith architecture, which we were discussing in all of the lessons up to this one, and also how you can maintain it over time as your project continues to evolve. We're going to discuss the 3 high-level ways of how you can enforce your software architecture, and I will also discuss the included costs and benefits of enforcing your software architecture either manually or through some automated way. This is the conceptual diagram of the system that we have built so far. It contains 4 modules: the events, users, ticketing, and attendance modules. And so far, we have managed to maintain our system pretty loosely coupled. The modules integrate or communicate with each other using integration events. We are also duplicating some data between modules to prevent coupling at the database level. And it would be in our best interest to have a simplified way of how we can continue evolving this architecture while also maintaining the architectural constraints that we have put in place between our modules and also on the system level. Here's another view of what our system looks like. We have our 4 modules as components inside of a single executable application, which is our ASP.NET Core Web API. Each of our modules has a dedicated schema in the database. Even though the schemas are living in the same database, we are still able to enforce logical isolation between them. I did mention that nothing was preventing the ticketing module from directly querying the events or attendance schemas. We could solve this by introducing separate connections for each of the schemas and then assigning those connections only to the respective modules. So this would be one way to improve the modularity of our design and increase the isolation between the modules. But as your project continues to grow and you keep implementing more and more use cases to satisfy the required business functionalities, it's also very likely that your team will increase in size. And we can't really expect that all the developers on our team will know how to maintain the current architecture. So it's very important to come up with a way or some rules that we can put in place that will help all of our team members make the correct decision at any given point in time. So let me introduce the 3 ways of how you can enforce your software architecture inside of a modular monolith. And the first way is by using the C# compiler and what it has to offer, and also the static code analysis capabilities that we have in .NET. The second way is architecture testing that we will discuss in one of the next lessons. And the last and also my least preferred way of architecture enforcement is using code reviews. We are going to discuss the first 2 approaches using the compiler and static code analysis and writing architecture tests in separate lessons, so I only want to briefly comment on code reviews as a means for architecture enforcement and we won't be mentioning them outside of this lesson. Another remark I want to make is the order in which I have listed these strategies for architecture enforcement. If you think about it, they are ranked from least expensive to most expensive when it comes to achieving the desired result. Running the compiler and static code analysis on your solution is both very cheap and extremely fast, and from a maintenance perspective requires next to no effort. Architecture testing is a bit more expensive, given that you have to maintain a suite of tests that are going to enforce your architecture. If you consider that your architecture can change over time, it means that you need to maintain this test suite for it to be relevant. But the bulk of the cost of architecture testing will be the upfront investment into actually writing your tests, although you can mitigate this by reusing your architecture tests between projects, but this is a topic for a different discussion. And from a speed perspective, architecture tests are very quick to run, and they can give you almost instant feedback if something is broken inside of your architecture. Which brings us to code reviews as a strategy for enforcing your software architecture. And I say that this is the most expensive way to enforce your software architecture because the price of code reviews is developer time, and this resource is both limited in terms of the amount of hours that your developers have every week, and also very expensive from a business perspective. And we didn't even mention that code reviews are also error prone because the quality of the output of a code review depends on the individual developer. So as I said, this is my least preferred way to enforce software architecture, and if I had to choose, I would opt for one of the first two approaches. And this brings us to the end of this brief introductory discussion about architecture enforcement. In the next lesson, we're going to discuss how a modular architecture, as we have designed it so far, can guide us into continue making good architectural decisions, and also what are some of the tools that we can introduce that can help us maintain our modular architecture as the system evolves.